So I'm going to start first by clearing my calculator, and then I'm going to read this. The census report for the population of Phoenix is given in the table below. T equals 0 to represent 1950. Now notice if you look at question 2 and then you refer to question 3, the way they represent time or years is different. In question 2, they've already translated this into T values. They have not done that for us in question 3, and we need to do that. So I'm going to come back here. It says T of 0 is 1950. So I'm going to change this right away. So T of 0, this becomes a 0. The difference between 1950 and 1960 is 10. The difference between 1950 and 1970 is 20, 30, and 40. Also, a key component to this that somebody else live in class was able to see is that when we actually get our answers, we know the population in 1950 wasn't 1.2 people. It's in millions, so it was 1,210,000. So let's go right now. I've cleared my calculator. Let's go to stat, and we need to determine next what type of model are we looking at. So I'm going to go to edit, and I'm going to plug in the information, 0, 10, 20, 30, and 40, and going to 1.21, 1.33, 1.41. And as I shared with you earlier, when I was rushing through this early this morning and doing these problems, I made a slight mistake which negatively impacted my answer. So I just went back to check. Okay, looks good. Now I need to go to Windows and I need to adjust this. So I want to just go slightly below this and slightly above this. So I'm going to go -10 up to 50, and that's going to be years. And then this is going to be population. And it goes between 1.2 and 1.7. I want to go just below that a little bit. So I'm going to go between 0 and 3 as I look at this, 0 and 3. And I need to turn on my scatter plot, so second y equals, and turn it on. And now I'm going to graph it. Oh, it looks like I did not adjust the x's, so I'm sorry. Let me change that here. We're going to go from -10 up to 50. Let's check now. Okay, I see it. So this is hard to tell. In fact, when I looked at it earlier today, I was like, is that logistics? Is it exponential? We can see it's slightly going up like this. It's slightly going up like this, right? And if you try even logistics, it will see that does not work. So which one makes this shape going up? And we can see that it is a growth model, right? It hasn't hit this high part yet, but we can see it's in this part of the growth. So I want to check to see, does exponential growth actually work for this? So how do I do that? Let me line up this problem once again for us. So I'm going to go to stat, go to calculate, and I want to try exponential regression. I'm not going to take time to write down the actual equation. I just want to plug this into y. So I'm able to do that by hitting bars, going down to statistics, going to EQ, pressing enter, and graphing. And remember, it's not going to hit every one of those points because it's taking like the average of them. This looks like a great model for this data. So I feel comfortable with this equation. I want to write this down now. So I'm going to go to calculate, back to exponential, and I'm going to press pause in this video, and I'm going to write down this exact equation up above. Let's go back here. According to this model, what will the population, please box in what we're trying to find. Population is the y. We want to know the y, and we're given the x, but I need to translate 2040, so 2040, into a t value. So how do I do that? I take whatever t sub 0 is, and I subtract these. So 2040 subtract 1950 is 90. This is my x value that I'm trying to achieve. So using a calculator here, I'm going to take this value raised to the 90, and then take it times this initial value. Grab your calculator. Let's do that. And taking time this initial value. Now, we need to think about what this is asking. What is the population? If you're live in class with me, when Viviana was looking through this problem, she said millions, and I told everybody to circle it. So I need to change this into millions. 1 million has 6 zeros. So wherever the decimal is, I need to move it to the right 6 times. So I have here, if I move this off to the side, I have 2 million. I move it 6 times to the right. 895,369. This is the population of Phoenix if we're using this model to estimate it in the year 2040. Okay, according to this model, what will the population, so what will, I'm going to box in what I'm trying to find. So I don't know what the population is, but I know the year is 1920. Now let's translate 1920 into a t-value. Well, if 1950 was year 0, what would 1920 be? Anybody here in class? Awesome, -30. This is my x value. So I'm going to do the exact same thing that I did for part A. I'm going to plug this in, do the math, and then multiply. Plugging this in, doing the math, and then multiplying. So I have 1.009852598 raised to the -30. And I'm taking a times this outside number, 1.198078004. And remember, I'm trying to find population, which is in millions. So I need to move this 6 times to the right. So 1, 2, 3, 4, 5, 6, 9, 2, 7, 8, 2. Now, remember for your AP test, it's very possible that you're just going to be given a calculator, and we can use this model to be able to calculate. So I want us to all do this together right now. We have this in. We need to adjust to make sure that our window has at least 90. So I'm going to go past 90. And I know in the next problem, I'm going to go to -30. So I want to adjust and go lower than -30. Okay, here we go. Let's figure out what is the output or the y value. Second trace value. Let's first plug in 90, which represents the year 2040. And we can see we get the exact answer. I'd have to move the decimal 6 places to the right. We still get this 2,895,369. Let's look at the next one. Second trace value, plugging in -30. Again, I move it 6 places to the right. We get the exact same answer, 892,272, or 82.